So this is kind of a result of some exposure to machine learning I had over about the last 6 months, or really more than a month ago, but for the 6 months before that. I was really surprised to understand that the way we manage software development and build traditional software has some severe impacts, or is some ways very different than how data scientists and others need to build machine learning models. Like, it is really kind of a surprise. So the machine training part is called build and train. And then like you have the build and train part where you train a model, and then you have the part where you actually execute a model in production. For build and train, basically what you do is you go and explore data and you massage data until you think you have extracted from raw data the driving factors that could be used to make decisions. So you have like all these transforms that have to happen, and then that massages the data in a certain way, and then that data is used to train a model, and then when you're in production, you make sure that you have the new production data is massaged in the exact same way so that when it gets fed to the model, it makes a good decision. So you have these transforms that happen on build and train, and those same transforms have to happen in the production environment in a controlled fashion, so that the model gets kind of the same inputs. And then we'll talk about production retrain. That actually makes it worse. So on the left-hand side is the non-production build and train environment, right? So what happens is a data scientist will go through data and they will start looking for driving factors, things that can be used as decision inputs into a business model. So if I was going to do home loans, is it income? Is it previous home ownership? Is it rental history? I don't know what it would be. Are there bad things I could pick, like census tract, which might be a version of redlining, right? So they'll go through the data and reformat it until they get what they think are the driving factors. So they may take a bunch of data and restructure it, but there's transforms. And then they'll kind of evaluate those features and try and figure out whether they align at some level with the decision-making process. And then they'll train a model and they'll evaluate the model. And then if the feature evaluation didn't work out, they'll try and change the inputs again until they figure out what they want. And then they'll train a model and they'll evaluate the model. So the weird part about training a model is you actually adjust, you're doing curve fitting, sort of, in traditional models. So you're doing curve fitting. So you adjust a bunch of the parameters around the exponentials and everything else around the curve until you get a curve fit that looks like what you want. So in non-prod, you actually take data and you feed it to the model training and you run a model training, but you may run hundreds of training cycles. So you'll evaluate the model and retrain, evaluate the model and retrain. So the inputs to the model are the data, the business data, and the training parameters. And so that can take a while. And one of the weird things about this is machine learning all happens. So humans are out looking at these inputs to try and figure out what they should be, right? To generate what they call features. And that means humans need, or human queries need access to production data. Like data that humans would normally not allowed to be able to see, you actually, or they might use QA data to play with in development. So software development would use QA and structure and scrub data, that kind of thing. Machine learning doesn't use any of that. It basically needs production data so that it can make decisions similar to what you want based on production data. And then on the production side, and so those input changes and transforms could happen in SQL. They could be Python code. I think I got another slide below where I talk about this. Another picture below where I talk about this. And then on the production side, you've actually got the model that you trained. So you trained the model and then you executed it to evaluate it on the non-prod side. I should put that in. The execution part happens on the production side, but what it means is so there's two inputs to the model, right? One is kind of the existing reference data, or like what the person's account number is, or their billing history, or anything like that. And another might be the new event. They've applied for a loan today, and we went out and we got a credit score. That might be like immediate, but there might be historical data or other data that we use to make that decision also. So the static data, the data that isn't part of the click stream, actually needs to be recalculated on a regular basis or updated so that the features can be fed to the model when somebody clicks on something. And so there's kind of like two sets of inputs. I'm pretty sure machine learning people will be upset when I say this. There's the input to the input for this particular transaction or this particular model run. And then there's sort of the reference or ancillary data, which is still at the same level of importance. And those are fed to the model, execute, and then the results are generated. Should you get a loan? Should you get an insurance policy? What should your rates be? What happens, though, also is over time the data may change. So during the COVID pandemic, people's buying habits may change, or their income may change, or there may be more risk factors involved. Somebody might get sick, and so what does that mean for impact for how many parts we need to order, ventilator parts we need to order, because we're using machine learning to figure out how many ventilators we need or something. So in real time in production, they actually analyze feature drift, and they will retrain the model. So you can kind of think of building and training as part of your CI/CD pipeline, right? But very rarely in CI/CD or in software development do you recompile the code and make changes in the production system as part of the production system. As a matter of fact, that sort of self-modifying code is something that is highly frowned upon. So there are differences here, right, between regular software development and ML software development. There's also differences between non-prod and prod, right? So in non-prod, we run a highly iterative process and humans have access to the data. In production, we try to do a more controlled environment. And so there are some issues around this, around governance. So transforms and models that are built and build and train often in a regulated environment have to be stored somewhere and approved. So all those hand-done transforms need to be collected, and the features that were used to train the model and the model itself need to be archived somewhere. And that's pretty unusual. I mean, we do save artifacts for code. Typically the source code only, though. And so in this case, it would be like saving the transforms, which would be code, and saving the models, which are sort of like binaries. All right. So in some ways, the pipelines for development and production are the same, but they're not. They both create features. They both train a model. So in the development side, we create features by hand. We train the model, and then we test a model. And then there's a debate always whether we should retrain the model in the production environment. So when you move from left to right here, the question is, this trained model, should it be executed in production directly where it was built by users? Or should this go back through a CI/CD pipeline and be retrained and rebuilt? Which means actually the model that was certified by the developers, by the software data scientists, would actually be a different model than the one that you built, that you actually deployed, right? Because one would be built by humans and one would be built as part of an automated process. So the other thing I want to point out here is the environment is actually pretty different. Here we go. So in the build and train environment, we do data analysis, we do feature construction, we do model training. A lot of that's very interactive. So a lot of people use things like Jupyter notebooks. They use collab spaces. They cooperate with each other. They share data sets to figure out. There's a lot of people involved. It typically tends to be Python or SQL code. Some places that are more software in it, it'll all be like Scala or Spark code. But that also brings up something else. When we go to the production environment, we tend not to run Jupyter notebooks or SQL run as a standalone thing. We have to run it in a productionized environment. So some places actually have to convert Jupyter notebooks to Python, or they need to convert to standalone Python, or they need to convert SQL and other things into Spark commands that they can then run in those environments. What that means, though, is you have this highly iterative process on the build and train side that is actually running different tools than on the production side, and that can cause mismatch. And so you can force this data scientist to use your software tools. That's really bad too, because you wiped out all the advantages of high frequency turnaround, right? And kind of the flexible environment. So this is actually a problem. And I talked this whole time, but this is actually what it comes down to. One of the things I want to point out is production data has actually got to be available on the build and train side, and obviously on the production side too. And typically you won't need PII for this, personally identifying information, but sometimes you'll have incidental PII. So like if you're doing call center logs and you're doing build and train, it turns out your build and train in human environment suddenly has access to sensitive information which might violate your policies in all other situations. So that's something to be aware of, where build and train is different than a regular data environment. And that's what I talk about here. The other thing that's kind of cool is you want to be able to do this retrain as data changes over time. So pandemic will change behavior. Economic upturn will change behavior. Boycotts will change buying behavior, right? And so you actually need to take into account that features can change, the data can change, the data disbursement, the distribution can change over time, and the model may need to be retrained. And so if you only train in the build and train environment, what do you expect to have happen for retrain, right? And so you got to have sort of those same pipelines running on both the pre-production and the production side. Or you can come back across the pre-production boundary and then re-execute on the pre-prod side and then do a re-promote. It's just something to be aware of. So the best models are the ones that are kept up to date. And then there's also that governance part. If you retrain a model with new data, does that need to be reapproved on a regular basis through governance? The goal here was try to explain a little bit of the differences between a machine learning build and train environment and the production environment. Have a good day.